Hey everyone, it's Justin again. In this lesson, we're going to be looking at additional attributes of exponential functions. We'll learn about how some of these attributes are closely related, what each of them mean, and how to identify them. Let's get into it. In the last lesson, we talked about these parts of the general form of an exponential function, whether the function was increasing or decreasing, the y-intercept, and the growth rate. Exponential functions that are increasing model exponential growth, while decreasing functions model exponential decay. Also, exponential functions will either be always increasing or always decreasing. Now, think back to what you know about functions. What other attributes of functions have we learned about? Pause the video and write your ideas down. What did you come up with? The first thing I thought of was the x-intercept. The x-intercept occurs where y equals 0. Other things we've considered in the past are the functions domain, which are the inputs represented by x values, the range, which are the outputs represented by y values, and whether a function is continuous or discrete. A continuous function can be drawn on paper without lifting your pencil, while a discrete function has breaks in the graph that make drawing it in one motion impossible. The last attribute we need to talk about relates to a function's restrictions. Let's take a look at a function from last lesson to discuss a completely new idea: horizontal asymptotes. So, what exactly is a horizontal asymptote? A horizontal asymptote is a horizontal line that the graph of a function gets very close to, but never crosses or touches. Take a look at the table for this function. What is happening to our y values? If we keep going further into negative values for x, the y value keeps getting smaller and smaller. 0.006 is, well, that's practically nothing. Actually, yeah, it does seem like these numbers are getting so small that they're almost 0. Do you think we'll ever actually have a y value of 0? Let's look at the graph. We're seeing those values in the way our curve is getting super close to the x-axis in this graph, but it doesn't look like it crosses it. In fact, we never cross or touch the x-axis. That's where our horizontal asymptote is, represented by the line y equals 0. Think about it. Even if we put in a really big negative number for x, like negative 100, that'd be 3 times 2 to the negative 100th power, or 3 divided by 2 to the 100th power. Will 3 divided by anything ever be 0? No, it's impossible. And this will be true for all exponential functions of the form y equals a times b to the x power. It is impossible to reach a y value of 0. Since horizontal asymptotes prevent a function from reaching certain outputs, it impacts other attributes that are connected to outputs as well, such as the x-intercept and the range of a function. Let's take a closer look at how these are all related for functions in the form y equals a b to the x. All exponential functions have a horizontal asymptote at y equals 0 and cannot cross or touch the x-axis. This has implications for the x-intercept and range. For an x-intercept to exist, a function must cross or touch the x-axis. Since the graph of an exponential function doesn't cross or touch the x-axis due to our horizontal asymptote, an exponential function cannot have an x-intercept. The range of a function considers its y values. An exponential function is continuous and always increasing or decreasing, and since exponential functions cannot cross or touch x-axis, the range has to be y values greater than 0, which we can always write as 0 to infinity. Let's revisit that function from earlier and take a look at the rest of its attributes. We already know the x-intercept, range, and horizontal asymptote since they're the same for all exponential functions. What will they be? Yeah, there is no x-intercept. The range is from 0 to infinity, and the horizontal asymptote is the line y equals 0. Now, we can identify the y-intercept from the a value. It's 0, 3. What's our growth rate? I notice that our b value in the equation is 2, so our growth rate is 2. The next attribute will either be increasing or decreasing. Those words are just a way of describing whether the function models exponential growth or exponential decay. I notice that the growth rate is greater than 1, and the y values increase as the x values increase. So we could describe our function as increasing. What's the domain? We could say our domain is all real numbers because we can substitute any x value into the function. Lastly, we know that our function is always continuous. Exponential functions are what we call a family of functions. Just like families of people, that means they share lots of attributes. Which of these attributes will be the same for all exponential functions? We saw earlier that we'll never have an x-intercept, the range will always be from 0 to infinity, and that the horizontal asymptote will always be y equals 0. Do you see any other attributes that might be the same for all exponential functions? Yeah, like with linear functions, as long as they're unrestricted, all exponential functions will have a domain of all real numbers, and they will also be continuous. Let's put this knowledge into practice. Time to fill in the missing attributes for this function. Take your time and pause the video to try it on your own. How did you do? Let's check. Which of these are the same for all exponential functions? We never have an x-intercept, the domain is all real numbers, and the range is from 0 to infinity, plus the function is always continuous. And lastly, remember that we always have a horizontal asymptote at y equals 0, and that line cannot be crossed or touched. Now that those attributes are taken care of, we can identify the ones that change from function to function. We can identify the y-intercept by examining the a value. Since the a value is 1, our y-intercept is 0, 1. All right, now onto the growth rate. You may have noticed that we have a growth rate of 1/5 by looking at the b value. Remember, the growth rate practically gives us the answer to our next question. Is it increasing or decreasing? Once again, we have to select whether the function models exponential growth or exponential decay. I see that the growth rate is less than 1, and the y values decrease as the x values increase. So we can describe our function as decreasing. It's important to realize that we only have a few attributes that vary from function to function. We can always identify the x-intercept, domain, range, continuity, and horizontal asymptote before we even look at the a and b values. Let's try another example. We need to determine which of these equations represents a continuous, decreasing exponential function with a y-intercept at 4 and a horizontal asymptote at y equals 0. Let's use the attributes we've learned about to help us narrow in on the right answer through process of elimination. Pause the video and try it out now. Okay, let's see how you did. Firstly, I noticed that not all of the attributes listed in the problem will actually help us choose the right function. Which of these details are not useful? Well, we have 4 exponential functions here, and they're all going to be continuous and have the same horizontal asymptote at y equals 0. So those details just don't help us narrow down our options. One of the details that really stood out to me is that the equation needs to have a y-intercept at 4. Which value should we look at to determine this? The a value tells us the y-intercept, so we're looking for an a value of 4. And since options B and D have a values of 3, we know it can't be either of those. That means our answer must either be A or C, and we can cross y-intercept out on our list. Now we need to find out which of these is also decreasing, and that's where the B value comes in. Option A has a B value of 4, while option C has a B value of 2/3. Which of those means the function is decreasing? A b value greater than 1 means that the function is increasing, so we can eliminate option A. And on the other hand, a b value between 0 and 1 means the function is decreasing, which means our answer must be option C. This equation represents a continuous, decreasing exponential function with a y-intercept at 4 and a horizontal asymptote at y equals 0. So it is checking all of the boxes. We discussed a lot today. Most of it we have seen before, but we needed to apply it to exponential functions in the form of y equals a times b to the x. In all exponential functions like this, the horizontal asymptote is represented by the line y equals 0, and horizontal asymptotes cannot be crossed. We know that exponential functions do not have x-intercepts since we cannot cross the horizontal asymptote represented by the line y equals 0. The range of y values always consists of all y values greater than 0, and the domain is always all real numbers. The last thing that's true for all exponential functions is that they are always continuous. That concludes our guided notes. You'll finish up this lesson with your online practice. Good luck with that, and I'll see you next time.
Hey.